Hello, dear students. My name is Andris Semenets. I am Associated Professor of Medical Informatics Department, and today I will present for you materials of first lecture on medical informatics regarding usage of spreadsheet application, not only Microsoft Excel, but in general, to perform statistical calculation and statistical data analysis. So the following main question will be considered during lecture. First of all, I will take a few minutes about introduce some specific spreadsheet function, which could be used for mathematical as well as statistical calculation. Then major part will be dedicated to performing statistical calculation and what is main aim of lecture, performing hypothesis test, statistical hypothesis testing. As then we will, I will try to provide some information about correlation, regression analysis, and optimal management task solving if it will be enough time for this. Let's start with first question. So first of all, I want to sign that actually almost all that I will talk about. Talking about Microsoft Excel, same way will be acceptable for almost all spreadsheet application like OpenCalc or even Cloud Google Spread, except some specific features. So several points about structure of creation spreadsheet application, arguments of function, and a creation wizard of its descendant component. So for sure we have how we like two different examples, simple and little bit complex creation. And as you can see here, our label common components, we start the creation with equal sign, then inside we follow with some symmetrical operator, function name, arguments, constant, and so on. In this case, mostly in given example, most time use two different functions with provided arguments, which is provided as reference to cell, and necessary operators which join into much more complex condition. In Excel spreadsheet, some part of function could be translated into national languages. In spreadsheet application like Google OpenCalc or Google Spread, all functions are available only in English, which is much better approach, in my opinion. And also, if you will be a little bit more detailed, consider anatomy of formula in Excel, and especially concentrate of Excel function. So every time, because for all statistical calculation, massive usage of Excel function required. So conventional Excel function consists of function name, or which entitle which kind of operation will be performed, which is followed by arguments in brackets. Arguments could be a single value or a range of values. In this case, we are talking about most complex combination when we have two a range which is separated, which is joined together into set or into pair of. Here is we talk about function which included two arguments, and each argument is referred to be an array. So this colon delimiter denote array or range between particular cell value. So also almost all spreadsheet application give for you some useful hints about syntaxes of function. So about a list of required arguments, and which it is strong and clear requirements. So if you have syntaxes of function, it's extremely strong rules how you must follow. So function name, then open brackets, then list of arguments delimited by comma or semicolon, attention, depending to regional settings, and then close brackets. It's possible to make encapsulation when one function, internal function, provide arguments for external and so on, but general sequence is strong. Also, sometimes even array function appears, so curly brackets will be used, and in this case, function will be upward not for single range, but for array instantly. Okay, so again, that as for me, it's almost all about general usage function. So what should be arguments for function? Constants like text or numbers, or what is most often time used as reference to cell, like address of cell or cells that contain data for processing. So sometimes I see that students made mistake and try to provide retype data which is available at worksheet. Greatest mistake ever possible. If we have data on worksheet, we must refer it by using reference, relative or absolute. Like conventional case relative, or in modern Excel also support nearest approach for providing reference, like R1C1 means row column, not only by alphabetical cell label and numerical alphabetical column label and numerical row numbers, but still most common used approach is this one. Same way we could use absolute reference if we need to refer, for example, some sort of constant in this particular calculation. So we need to prepend $sign to refer specific cell or specific column or specific row. So here is given approach how to create this. In statistical calculation, most time we should use as arguments an array. Or variances. We will talk about this in a few minutes. So in this case, to denote array, we use colon. And to denote set, we use semicolon. So colon means if we separate two cells addresses by colon, means all cells between this will be used as arguments. If we separate by semicolon, only specified cells will be used, or it's possible combine array with sets out together, and we will have the following combination of input data. So it's very strong requirements to be able to manage proper cell range for data processing. And actually every time researcher completely responsible to understanding which range of data must be processed. Again, researcher, every time, no matter which application software will be used, Excel, OpenCal, Google Spread, or even something specific. So, and from years, special equation wizard has been available in spreadsheet application, especially Excel. It's still available even in modern Excel. So we need to looking for F from X button, and then 2 steps dialog will be started. In first step, you can search for functions, select by category, pick exact specific function, and get some help, brief description of function, or got full help about it if necessary. At second step, you can provide the argument, and second step dialog every time will be different, because it will be depend to function, depend to number of arguments, depend to type of arguments, and so on. But every time it will be like list of fields when you must provide or constant value or a reference to cell, and by using this pick button, possible to pick proper range from spreadsheet application, directly from spreadsheet. So as for me, it's enough introduction about performing calculation in spreadsheet, and actually it's even requirements for course. So right now moving to second question, statistical calculation by using spreadsheet. Again, most time I will use common word spreadsheet, and I will refer to all spreadsheet application, and only if necessary I will be mentioned about specific features which is available with, for example, Microsoft Excel. So first of all, we need to denote quickly what is statistic, medical statistics, and so on. So statistics seen as branch of mathematics, which is scientific area, it's independent scientific area, but it's branch of mathematics which deal with collection, organization, analysis, interpretation, and presentation of data. And medical statistics deal with application of statistics to medicine and health science, including epidemiology, public health, forensic medicine, clinical research, and so on. And it recognizes as branch of statistics science field for decades. So even medical statistics are already separated from general statistics science. So very tightly related to statistics term probability. And so here is time to denote key difference between probability and statistics. Probability, when we talk about probability, it's a measure of likelihood that events will occur. And it's studied under probability theory, which is also, in fact, independent scientific area. So probability theory, with probability we measure is that we have some reasons that something will happen or will not happen, and we provide some measures about this. Under statistics and probability are two related but separate academic disciplines. Statistical analysis often use probability distribution, and two topics are often studied together. But so at the chart below, given explanation about, like, we have with probability we have model and we want to predict data. So we toss coin, we want to have expectation about which reverse side or front side or back side based coin will have. With statistics, we are collected data, we are given data, and we want to retrieve scientific model, statistical model, which will explain behavior of this data, why we got this. So in statistic key points, we are given data, we collect data during, for example, scientific experiment, and we want to construct some mathematical model and use this model for simulation. For example, for prediction too, but not only. So again, some brief labels, definition, even not definition, labels, notice about common terms which is used under statistical analysis and especially within descriptive statistics. So first of all, when we talk about statistics, every time we talk about measures of sample characteristics. Measures of characteristic of sample or population. Actually, it will be even more correct, or sample or population. So population contains all members of group, and in some circumstances, we can perform statistical analysis of whole population. If we have a relatively small population, it's possible. And if we can examine each one member of population, it's possible. But more often, we have too large population. For example, if we talk about statistical assessment of social studies or so, and we only can perform analysis by using subset of population or sample. So we extract subset from population, which must represent for us whole population, and we perform analysis by this sample. So we measure sample characteristics with statistics if it's sample based. And variable, it's characteristics that can form different value from one observation to another. So samples every time for us will represent one or several variables. And when we conduct scientific experiment, when we conduct some observation, we every time will have some independent and response variable. Independent variable, it's measures that can take on different value which are subject for manipulation by research. And response variable, that's measures not controlled in experiment, or it's also sometimes use the term dependent variable. So we can't perform direct control on response variable. We are only change environment, change our independent variable, and we assume that dependent variable must be changed. But most time, so we collect all this data, pairs or sets of independent variable, response variables, could be more than one, and they will form our samples and being processed within statistical analysis. Before we will move forward, it's important to get some recap of even school knowledge about type of variables, because they are critically important, because different methodologies could be applied for different type of variables. And first of all data types we can split into two large categories, two large groups: categorical or numerical and quantitative. So, and the categorical we consider like binary with two categories, and the nominal we could have more than two categories, and the ordinal become important order like first, second, third, with quantitative, discrete, and here we have two groups: discrete variables, discrete values at specific moments, and continuous values uninterrupted. So quantitative data types represented by numerical value, and we could apply various mathematical operation over it. If we talk about more detailed about this data set, so categorical or qualitative, also qualitative, we can consider like treatment group, exposure groups, disease status, and so on. Dichotomous binary represent two levels, yes or not. For example, there did live, treatment placebo, and so on. Symptoms present, not present, etc. Again, we are talking, for sure it could be even represented by numerical value like 0 or 1. But here it's clear that it's not numerical, and it's like we cannot perform, for example, summation or multiplication for them, for that variables, even if it's formed by numbers. Categorical variables. Order, it's not important in this case, like blood type or marital status, or much more, which we have nominal variables under it. And order matter for ordinal variables like staging in cancer, or birth order, or letter grades, or even numerical grades. So grades you earn on practical classes, like 1 to 3 and up to 12, despite they are labeled as numbers, they are definitely ordinal variables, because they are issued most time by expert, by a teacher. Even if you pass some part of class with Moodle quiz or so, the final mark, final assessment made by teacher. So in this case, we deal only with, or definitely with, ordinal variables, and order here matter. And also it's a significant point that not all statistical methods is applicable to provide them statistic for students' grades. And it's the reason why ratings more correct to provide assessment of students' grades rather than, for example, assessment of average mark. mean adds after we complete discipline. Okay, for quantitative variables, it's numerical variables, so we can perform arithmetical manipulation like count, times, time, and so on. So here we identify discrete numbers, symmetric set of distant values, such as whole numbers, for example, number of new coronavirus case, and so on. Here, school complete, and so on. And continuous variables can take on many numbers within a definite range, like age, time, and so on. So we since we measure time, but we have microseconds and less time, even shorter time periods. So time is continuous, definitely variable. Same way, blood pressure and similar things. We measure statistical part, we measure some value, so we got with some discrete interval, we perform measure, we perform assessment, but in fact, in origin, all these things, it's continuous. So now we move closely to perform descriptive statistics, to perform statistical assessment of samples. So here is 2 points which actually even not belong to me, and I just reuse this information to the rules of statistics. First of all, use common sense. Here that means before you will start some kind of analysis, think about does it make sense? Because very often if you have like numerical data set, and calculation tool like Spreadsheet, and set of function for processing, definitely you will be able to make some calculation and got same result. But does it make sense, this result? It's actually a significant question. We can calculate average for maybe all numerical data that we have. Does it make sense in this particular circumstances? As I mentioned just a second, every time we can calculate average for students' grades. But does it make sense? Despite nature of students' grades. Second rule, not such critical, and it's related only for our human nature, like about 90% information contained in graph. Yes, definitely. If human look at this data, for us, it's much more easy to identify trend, tendency from chart. But if you will use analytical approach, if you will use analytical software to perform statistical analysis, the only first rule have matter, common sense, because will be insignificant if you will have 1,000 or 1 million record for processing. Spreadsheet like Excel will done results in seconds. Okay, so example of conventional example of visualization, for sure, very often if you have some numerical data set before even starting some advanced statistical analysis, it's not a bad idea to draw some chart and made assessment about and identify possible trend or like assume what we can do with this data. So here is the example which chart is better applicable for specific data. If you talk about categorical variables, but chart preferred continuous, something like stem and leaf, box plot, frequency distribution. So no, histogram, it's actually in fact a frequency distribution. So again, check this list of chart. Again, bar chart. So here is important to understand that bar chart and histogram looks very simple, very similar, sorry, looks very similar, but they are absolutely different type of chart. They are critically different. And if you will mix it and use one instead of other, it will be a great mistake. Okay, with bar chart, we use categorical variables to show frequency or proportion in each category and translate data from frequency tables into pictorial representation. We have something like this one, a 10 shock index, and how many patients affected by this shock index, or how this shock index. So here is, in fact, we must understand that x-axis, when shock index presented despite its number, it's categorical axis, it's categorical variable, and we can replace then this numerical representation with like text definition almost not exist, minimal, light, medium, moderate, significant, hard, extremely hard, dead live, and so on. So in this case, we can replace numerical labels with text labels, and we will still get exactly the same results. Same reason when we talk about students' grades, same way we can replace place students' grades from 1 to 12 and number of students that get this grade, for example, for particular class or for particular topic within all students group. It's one more reason why grades, it's also categorical data type. With continuous variables, Stephen Leaf, we have continuous variables. So, for example, age, it's represented like discrete number, but we keep in mind that age, in fact, time measures, in fact, every time it's continuous variable. And we have example how we can draw it STEAM, like the number of decades we use as STEAM and number of single years we put as leaf, and we have this visual representation. Practically, in current time, use it in rare condition. But what is used more very often is histogram. Histogram, it's used to display distribution, or let me have shape, center, range, variation of continuous variables. And here we within x-axis we use some intervals of measures of our independent variable, and the response will be provide us frequency of observation which is occurring in contain range of independent variable. Here arrays per minute, no matter what is it, arrays of what, if you talk about students to class or patient to hospital, emergency department, or some airplanes to airport, or so. So here is how frequency what happened. So, and summarize it, for interval level data, measures of central tendency and variable are common descriptive statistics. Measures of central tendency describe a series of data with a single attribute. So that attribute is exactly central tendency. Measures of variation describe how widely data elements vary from that exact central value. And standardized scores combine both central tendency and variation into single description that's comparable across different samples with same or different units of measure. And for nominal ordinal data, proportions are common methods used to describe frequencies as they compare to a total. So maybe not very fine understandable, and we can draw it with the following chart when we will list most common approaches to describe data numerically, and we have here presented most commonly used methods for perform assessment of central tendency as well as variation. I sign not all, just most common. Like we have arithmetic, geometric mean, median, mode for central tendency, range, interquartile range, variance, standard deviation, coefficient of variation for variation, skewness, kurtosis for shape. Even I mentioned things which is not drawn here. quartiles that stayed slightly outclassed. Even we can extend and make this chart a little bit more complex. So let's again check and remember how possible to calculate some of this assessment characteristics arithmetically, or how, and then we will consider how spreadsheet software could help us. So mean, median, mode as common central tendency assessment method. For mean, given formula, sum of all items divided by number of it, median point on a scale of measurement below which 50% of scores fall, and mode, most frequency occurring score in distribution. And we can depict it in the following this following chart, when we have again variable range age as variable, and for us given sample of observation which is obtained during our experiment, scientific experiment, and we have number of scores or sample size. Then we have sum of score and mean. For sure, for such simple case, it's easy to calculate. And here is we have more than median, like half of scores left above, below 42, and we have only two values which is repeated twice, at least twice. So reason why do we need multiply assessment even of same single characteristic like central tendency? Because specific characteristics could be affected by outliers, by extreme value. For example, mean, we compare mean to median. So mean could be very easy affected by presence of outline. Once we add one extra outlined value, mean immediately affected significantly. So in contrast, if we use median assessment, so median will be the same for both cases. And when we compare mean to median, or if we add there even mode, we can, even without presenting of our data set, we can provide information, useful information about structure, about shape of our data. So is it there present some kind of outlines or not? So if you have median equal to mode and to mean, we talk about like symmetrical distribution and very well symmetrical data set. But if they are does not equal, we talk about some unsymmetrical structure, and okay, it's raise question about what kind of distribution will be applicable in this specific condition. So another assessment, it's measure for variability. It's measure provided by calculation dispersion and various assessment of dispersion like range, interquartile range, variance, standard deviation, coefficient variation, so on. So we use variation which give information about spread variability of data value. Here is we have two different histogram of two different sample data set where our central tendency absolutely equal. So every time mean, mode, median equal for both this case, but they are definitely not the same. We have absolutely different data structures here. Quartiles. So for further analysis, very often we use interquartile range, and for this we need to make assessment of quartiles, and there we split data sample into 4 quartiles when each of it contain 1/4 of our full data set. So here is given explanation about how we are seeing data for quartiles, And practically, we most time use range and interquartile range. So range, in fact, it's different between smallest and greatest value, maximum and minimum. But every time we must keep in mind that that data set could include some kind of outliers, and typically they will be greatest and smallest value. So interquartile range also provide very useful assessment in contrast to full range. And it's different between first and third quartile. So interquartile range, difference between first and third quartile data. So here is shown, and here is immediately we have started to provide drawing of box plot, which refer for us box inside refer to interquartile range, and we have median at the center, which provide for us like distinguish point of our at every time should be equal to second quartile, and also for us we have maximum minimum value, which is play a role of so covered term used whiskers with attached to central box. And here is we have another representation of box plot, like we draw that mentioned shock index. We can replace with the following box plot. When we will have number interquartile range, median, and we have assessment of minimum and maximum. And here is we have signs that in this specific case, so here is given formula to make assessment of appropriate minimum and maximum, and we have set of outliers, and maximum, real maximum lie significantly behind than expected maximum. So such kind of drawing, it's very common for scientific papers. It's allowed to present information about data set that has been obtained during assessment and which will be performed further statistical analysis on that data. Well, we no need like thousands or millions row of data. Most time to box plot enough to provide for us maximum useful information about this. So, in addition to previous chart, some variance and standard deviation formula given. So, given formula for variance, standard deviation, it's only square root of variance. Variance provide average of square deviation between individual scores and the mean, and range of variance more variables than there is among the scores, and standard deviation square root or normalized actually in fact version of variance provide representation of variance among scores that directly compared to the real scores. And here is how we can again draw distribution with frequency distribution with histogram for age and percentage of occurrences, and how manually we can calculate variance, standard deviation, and so on. So actually, I have this experience when my university time. It was almost very hard to access computer and even calculators. Not every time will be accessible. So most time I follow this way, but actually it would be fine to remember how possible to do it. But actually right now with usage of spreadsheet software, you no need to such deep dive in simple calculation, and you can do it much more easy. And still we back to explanation again, why do we need this variability assessment? So here is 3 cases with 3 different samples with 3 different set of data, and how real data could affect variability characteristics of especially standard deviation. And here is we have exactly the same mean value, but absolutely would be fine to decide that mode and median will be also the same in this case, but only standard deviation give us information what is in fact how represented our data in these data sets. And here is given on slide the conventional labels which used in different literature to denote variance, standard deviation, population variance, population standard deviation, sample mean, population mean, and equality range. Again, thankfully to spreadsheet application, we no need to calculate most of this descriptive statistic assessment manually. We need just pick proper function, for example, from this list. It's not all, it's just like few most often time used, and immediately you will get response. Every time, for sure, every time arguments must be provided, every time arguments is variable data. Reference to variable data must be provided every time as argument. Okay, now time to move into topic. So with descriptive statistics, we got assessment about some variances. We got some essential characteristic of variance, like central tendency and variability. And typically, it's not enough to make conclusion. Typically, we need, for example, made assessment about, okay, we have new medicine, for example, call it vaccine. We need to check, is it effective, provide effective treatment, or is it better treatment than already existing methodologies, and so on. So we need to compare different sample assessment. We have descriptive statistics for multiply samples, and we need to perform some comparative analysis as assessment. And in fact, we start to talking about hypothesis testing in this point. And actually we need, first of all, we need to identify distribution type of statistical data set or population if we deal with population. So it's distribution, it's listing or function showing all possible values interval of data and how often they can occur. And frequency distribution is grouping data into mutually exclusive categories showing number of observation in each class. And here we actually need to provide compare to most common distribution. Every time researcher try to look around and provide proof that his data belong to the normal distribution. So we have numerous sample distribution in hypothesis testing. A normal distribution, most common example how data would appear if we create a frequency histogram where x-axis represents value of score and y-axis represents frequency of score for each value. So most scores will be similar, therefore we will group near the center distribution. Some score will have unusual value and will be located from center to or apex to the distribution. Practically it's look like this one, and even we can provide assessment about normal distribution like 68, 95, 99, 7 rules, like 68% of data must belong within one standard deviation from the center model or average, 95 within 2 standard deviation range, and almost everything 99.7 within 3 standard deviation range. So we will talk about well-curved and normal distribution. And here is actually, in fact, explains these things when properties we have properties normal distribution forms a symmetric bell-shaped curve, 50% score lie above below the midpoint, curve asymptotic but never cross x-axis, means median mode located at the midpoint, and all 3 values fall within standard deviation. No matter what is u, like population and sample standard deviation, area will be work between we have difference between population and sample standard deviation. That's I already denoted. In real case, for sure, every time we have some deviation from ideal case, and then we have left or right skewed distribution when median does not equal mean, greatest or smaller. And here is shown when we will have left and right skewed distribution. So, what is hypothesis testing? We come to that question. It's used to establish whether the difference exhibited by random sample can be inferred to population from which sample originates. So, in other words, we can decide is a difference it's really significant. Difference in specific sample characteristics, so we can perform assessment and hypothesis testing against like mean, mode, median, standard deviation, variance, so different of each of these parameters. Descriptive statistical characteristics could be used as distinguishing criteria here. And chance variation for inference of statistical sample must be randomly selected, and sample estimate is compared to underlying distribution of the sample size sample distribution and determine probability that the sample estimate reflects population parameters. Or in other words, we can talk about simple things, representativeness. So our sample must represent all possible cases which could be occurred within general population. So in this case, we can use sample as small sample. We can use a smaller sample regarding to general population as tool to provide assessment for whole population. So in the following, when we talk about usage of conventional methods, we made assumptions that population normally distributed. We already complete correct random sampling with fit representativeness question. Also, we have mutually exclusive comparison samples and data characteristics match statistical techniques. So actually, we follow good experiment practice. But in fact, if you talk about how each one of this question, it's like was separate lecture, definitely. And then depending to nature of data, we talk about categorical or continuous variable or interval, nominal, ordinal data, different methods could be used like test statistics, interval test statistics, Pearson correlation, NOVA, regression. For nominal ordinal, difference of proportion, chi-square and related measures, Spearman correlation or other methods will be used in this case. So here is like simplified steps for hypothesis testing, like we need to state no hypothesis and look the data and decide the appropriate statistical test. It's actually a black box because inside this second steps we have lots of small action must be done, will be considered in minutes, and then compute proper statistical test, got significance value, compare significance with rejection criteria or alpha level. It's typically 5% or less. Latest time we appreciate to use like 1% rejection criteria. So in this case, we reject null hypothesis and or if we have significant results. If significance less than rejection criteria, so we have significant result. In contrast, we are failed to reject null hypothesis. Attention, it's significant point. It's not means that we must accept alternative. Here is it's like a situation when we doesn't have enough evidence to make correct decision. When we have insignificant result, p greater than alpha. We have insignificant result. So we just report our result and that's all. It's like not fail of experiment, it's just like not enough evidence, which is very, so this condition, it's very things which research every time want to avoid it, but it's happened too often. Okay, so that second steps, how to identify proper methodologies to perform statistical hypothesis test. Here is again part of algorithms, and next slide will provide some extension, but in fact we start with question data type, categorical or continuous. For categorical we continue proportion to growth, for continuous we compare means or median in groups. And for categorical data, depending to number of groups, we typically use, for example, chi-square test. In case of continuous data, we compare means or median in groups, and depending again to how many groups, we must use depending for 2 or 3 groups, we must use OR. And then as it we have normally distributed data, or we have deviation for normal, so depending to this we could use test statistic or Wilcoxon test or conventional analysis of variance or specific classical levels test, or even more. So here is again we have just some partial area, some partial table which could help us with decide which kind of methods is applicable in specific condition, and sorry. Please check carefully first, second, third column. And especially last. So here is that things I'm speaking about problem with statistics. In last column, proprietary method, every time if you refer statistic textbooks, every time you find that it's formula. So with presence of data and formula, we can get every time results, but all 3 columns before represent condition when this specific method could be applicable. And here is we can method like compare control experimental samples and compare samples data before and after experiment. So if we have like 2 group of person, 1 given medicine, second placebo, we talk about control experimental sample. When we have single group and it's given, it's measured before and after taking medicine, we compare data before and after experiment, and so on. If you want to prove that it's our medicine give changes for specific vital parameters with specific denoted value, it will be comparing sample mean to constant, and so on. It's even not full list. In the construction you will find a table, full table, which have 6 elements. So what is next essential steps in hypothesis testing when we decide about method which must be used? Then we should create statement for hypothesis, something like no alternative, no difference, alternative, present difference. Maybe it's more better talk about there is no statistical significant difference between, and then when we have like empty places must be located name of statistical parameters, which is in fact obtained from previous chart. From here, if you talk about like compare independent sample mean, or compare dependent sample mean, or compare independent sample variance, so that statement or independent means or dependent means or variances must be placed in this specific position, in this given position. As I mentioned, that rejection criteria determine how different parameter and non-statistic must be before the null hypothesis can be rejected, based on alpha level, and we use alpha 5% or less. 5% or less, depending of our conditions. So in a conventional situation, when we compare, is it our null hypothesis statement stated like there is no difference in population mean and alternative. So there we're talking about population, because normal distribution every time refer to population. And same way, an alternative, we talk about that's present statistical difference between mean for population, like experimental compared to control. Actually, greatest or smaller in this specific case, no matter. No matter, it's only mirroring this chart from left to right. And here is we have like rejection area when we have our calculation less than 5%. In case if we want to decide equal does not equal, we must split rejection area into parts, and we will consider like alpha by 2. So it's situation when we want to get answer, is it like population mean equal or does not equal? And all three combination combined within single slide. When we have our situation, when we have equal not equal at the center, two tailored, so covered two tailored test, and left and right tailored test, one tailored test, left and right. When our observation, we decided it's smallest from control or greatest from control, depending what is better for us, what is actually goal of our investigation. So now about what happens if we provide wrong decision. If we reject null hypothesis and concluded that there is enough evidence to infer that alternative hypothesis is true. But when we fail to reject null hypothesis, we concluded that there is no enough statistical evidence to infer that alternative hypothesis is true. And it does not mean that we prove that null hypothesis is true. We just, it's like third state. We are not sure. We doesn't have, it does not have enough evidence to make any conclusion. And if we are made mistake to made one of this decision, we talk about we commit type 1 or type 2 error already, which is very bad things. So here is we have like in gray, we have correct statement when we reject false null hypothesis, or not reject it if it's true, and if we reject true null hypothesis, we got we reject true null hypothesis, it's type 1 error, and we don't reject false null hypothesis as we type 2 errors. So description actually quite complicated. When we talk about reject null hypothesis, like published paper saying men, women really different, need treatment really better than old, and we are wrong that it's type 1 error. Type 2 error happens when difference is so small that does not matter much, or it's very hard to detect, or difference is big enough to care about, but sample size was just too small to tell you so much, or we have uninformative null findings. And here is given example for some people have climate, women are higher risk of Alzheimer's diseases, and careful analysis in large studies show that, however, women have more Alzheimer's diseases only because they live longer. This is an important finding and needed to be published, but not, in fact, it's not related to gender, but to age. So if we just for fun, we can denote type 1 and type 2 error like this chart. But in reality, it will be not such objective and easy to understand case. It will never happen such easy and objective. And it's very hard sometimes to determine is it we really allow it to reject null hypothesis or not. And here is given 4 possible situation and 4 possible outcome about depending to significance that has been calculated and same alpha level and probability of type 1 error given at the center in central column, and what is which conclusion we must provide, like when we have a p-value significance value equal 5 or less than 5, so we have minimal chance that it's difference not significant, so our result is statistical significance. And in contrast, when we have about 10 or even much more percent chance that probability, we have very large probability of made type 1 error, so our results not statistical significant again. So it's not means that we reject null hypothesis, accept alternative or so. It's not statistical significant result, no evidence for conclusion. And finally, it could be drawn with the following line chart when we showed about like no evidence, weak evidence between 5 and 10% error, strong evidence from 1 to 5, and overwhelming evidence highly significant. But also we have in this area we are in risk of overfitting of our model. So very small significance value. It's also made some suspicions at some. Okay, now actually I am spoken a lot about like statistics theory and so on, because hypothesis testing, in fact, it's 95% it's statistical assumption and determining of proper statistical model. Calculation itself with usage of spreadsheet application is pretty easy and could be done very, very easy. For example, if you talk about Excel spreadsheet application, available tool-colored analysis tool pack, which contain built-in features to calculate specific hypothesis testing characteristics. Also, such extension available even for Google Spread cloud application, but not in standard package, but could be installed as extension. So, for example, in conventional spreadsheet, we need enable analysis toolpack, and you will have this dialog which allow you to select several most common used methodologies for perform statistical analysis, different methods for which is applicable for continuous as well as categorical variables. So we have here, we could perform assessment of central tendency as well as variability assessment. So we have methods for test statistics, Fisher test, analysis of variances, and so on. Okay, if you talk about perform hypothesis testing, so what is supported by analysis toolpack? Fisher test for variance, analysis of variance in case if you have multiply variable more than 2, test statistics for at least 3 test statistics, and Z test for equal and unequal variances, and 2 sample for mean, and so on. The correlation analysis available, etc. Okay, so let's consider if we have some sort of data set, like we have made some Wood parameters for male and female. We have assumptions that Wood parameters depend to gender, and we want to perform some hypothesis testing. So first of all, technically, it could be done very easy. First of all, let's compare Fisher test for variance with test statistic. We assume an equal and equal variance. Input dialogues to provide data very similar, and we have only minimal difference for test statistics like about hypothesized mean difference and so on. But practical usage extremely significant. For example, when we talk about Fisher test, we every time must refer for statistical meanings of this test. We compare variance in two samples, and actually we calculate fraction of variance. So in this case, order of sample is critical, and in this case we need to provide variable 1z range, which is have greatest variance, and it's the reason why below this data sample we have calculate few descriptive statistic parameters like skew, kurtosis, and variance, because it's important to know. So in this case we have greatest variance of hemoglobin for women. So this range, this data sample for women must be used every time as variable 1 in Fisher test and never as variable 2. Hemoglobin for men will have smaller variance and every time must be used as variable 2 range. If you will follow another order, which is major problem that Excel and Toolpak will not generate error exception, you will be given value which will be in fact absolutely incorrect. For test statistics, in contrast, order of variables, it's not such significant. If you provide variable range even in incorrect order, maximum what you will have, it will be negative result, which in fact every time we use absolute value of test statistics, so every time we dismiss any negative sign. So no, order here not so critical if you will use it's not in proper order. What I want to assign here, if you want to perform calculation even by using data analysis toolpacks, you must refer to origin of this method and you must examine limitation and requirements for this particular statistical assessment method to understand that you will use this data analysis tool properly. Because very easy to, let's say, incorrect result. You will have like you will get this numerical data which will be incorrect. And here is we have for that previous case. Here is we have correct case of calculation when we perform Fisher test to determine is that we have variance statistically equal or not, and before it, why even we use a Fisher test, why we use test statistics, because in our case definitely we have compare control and experimental sample. So please refer back to my previous explanation. Then we have two variables, two samples. Then we assume that we have normal distribution. Actually, in this reason, we use assessment of skewness kurtosis. It must be tested against statistical reference table, and we when our skewness smaller than critical and kurtosis between given range, we get proof that our data belong to normal distribution or is closely to normal distribution, or if we have discrete data, it's in fact binomial distribution, which is reflects normal distribution for discrete data value. And here is the reason why do we need to use test statistics. And before we will decide which kind of test statistics we need to use, we need to perform sample test for variance. And in our case, for us, what is our outcome? Like Fisher test, we given Fisher test value, we given F critical value, and if so here is Fisher test F, we have given critical value, Fisher statistics smaller than critical value, we can assume that variances are statistically equal. I signed statistically, we have two different variants, but statistically they could be covered as equal. But significance value is too large, too large, 44% of to be wrong. And in this case, like, we can't no reject, no accept null hypothesis, no reject it in favor of alternative. We just that's in that third state. We just in that third state. So we don't know is it actually we have enough evidence to assume that variances are equal. Okay, despite this, researcher assume in this particular case still use test statistic for assuming equal variance, but because major test must be against, not against variances, but against mean in this specific case. And what we want to prove is it means are statistically equal or not. Arithmetically, they are equal. And here is again trap of statistics. We can't compare descriptive statistic directly. Here is reason why do we use hypothesis testing. Because definitely every time arithmetical value of descriptive statistics every time will be different. But with some probability they could be considered as equal or not equal. Here is why we do all this. So in this case, when we start test statistics, so what we get? Test statistics detailed, because we actually check about equal does not equal. So here is we split alpha level by 2 in the chat below. And so we use this part of response, which is provided by data analysis toolpack method, and we have critical to tailored, which is 2.0, and our test statistics significantly greater than the clinical to tailored. We should reject null hypothesis and also examine significance level. Yes, it's also very, very small. We have 3 zeros since decimal dot. It's overwhelming evidence that we have strong evidence. Okay, we could be ensured that in this particular case means really statistically different. So we have real statistical difference between men and women in case of their blood parameters. So blood parameters depend to gender. So how possible to make all this outcome? Okay, now move into third topic of lecture, correlation and regressional analysis. So we need to check about what is correlation, understanding overfitting, and check what is Excel offer us to perform this kind of analysis. So correlation is a statistical technique which can show whether and how strongly pairs of variables are related. And main results of correlation covered correlation coefficient marked as R, and in range from -0, absolutely negative correlation, it's like mirroring of data, with absolutely positive correlation, with we have like extremely data follow 1 and second order, so close nearest to 1 or -1, the more closely two variables are related or concentrated. And here is we have two main type of correlation coefficient. The correct usage of correlation coefficient type depend to type of variables being used. So again, we must check type of distribution before we will decide what we should use. Pearson product moment correlation when data normally distributed, and Spearman's run coefficient correlation when appropriate, when variables are skewed or ordinary, and is robust when extreme value are present. So I find Spearman run correlation efficient not only for skewed data, but for ordinal data, which is categorical data. Pearson's only for normally distributed, continuous, and discrete value. Here, given a formula sense we can use for calculate Pearson's correlation as well as Spearman coefficient of correlation, and how to make decision about is it we have a negligible, low positive, moderate, high, and very high positive correlation, or negative correlation depending of value sign of correlation coefficient result. For sure, manually calculated will be not easy, but with Pearson, spreadsheet could help significantly. With Spearman, not yet, and you will need or looking for extension or calculate manually, yes. So, for example, Excel, our spreadsheet application support correl function when two variables could be provided and correlation coefficient will be calculated. In this case, for sure, given how look like ideal positive correlation and ideal negative. In ideal positive, one variable strictly follow another. In negative, they are reflected like during mirroring. If you have more than one variable, Excel offer data analysis to pack correlation when you can provide a range for analysis. And in fact, what you will say, it will be matrix of all possible pairs of correlation coefficient for pair of variables like B and A and C, and B and C. So we have three correlation, and we can decide that we have strong positive correlation for A and C variables, and we have like almost negligible correlation for A and B as well as B and C, and which is in fact fine confirmed by chat. So next meeting, when we made conclusion about presence of correlation, it's we can made attempt to build a mathematical model and perform curve fitting or process of trying to find curve which represented by some model of equation that best represents the sample data, or more specifically the relationship between independent and dependent variable in data set. So when results of curve fits are to be used for marking new prediction of dependent variables, this process known as regressional analysis. And we have more common model like linear, logarithmic. Formulas must be known even from school. Power, exponential, and same like very often polynomial distribution. So actually major goal of curve fitting is identify all this coefficient B, C1, C2, or in previous corresponded coefficient in previous case for logarithmic or power or other models. With curve fitting we want to identify this coefficient and fit our model with our real data. What do we have? So if you want 5 listed model curve fitting, easy to generate using threadline feature, which is built in Excel XY scatter chart. Also, it's available in Excel bar chart or line chart, but here is important to understand that again everything depends what kind of data do you have, and linear chart as well as bar chart in Excel applicable for categorical data. In case if you have continuous discrete value, XY scatter plot is correct only to be used. So when you draw data with scatter plot, then you can add thread line, display equation, and Excel automatically provide for you results. So here is like detailed points about how to create chart. So again, I sign here wrote about XY scatter or linear. It's depend to what data type do you have in your data set. Is it quantity or categorical variables? And here is data thread line, and here is we have case for modern spreadsheet application when we can add the multiply type of thread line. We can choose from given section. We can immediately provide visual forecasting, like in this case we given forecasting for 2 forward period, and also we can display equation square value. So here is we have like polynomial third order. And what actually Excel already done, it's calculate this expected coefficient value to fit polynomial third order model with our data. So R square value provide assessment quality of model. It's like different between data calculated by model and which is obtained in reality. So if it's square of correlation, normalized coefficient of correlation, and to avoid the situation when we have negative sign. So in this case, obviously, so closer a square value to 1 then means our model is best fit our data. And here is how various trend line could follow original data, which is marked by filled rhombs and straight line. So, and here is we have multiply model, and in this particular case we have like so which is linear model provide best fit in this case. That's very simple case. So what is also actually important is to try to avoid overfitting. When you will use especially highest order of polynomial, like highest than third, like fourth, fifth, sixth order supported by x, definitely your model will be extremely fine. But it's definitely overfitting too. It will be very clearly visible when you will try to create prediction. You will be most time you will have extremely very fine in your prediction, extremely difference in your prediction. Okay, and so 10 minutes of lecture left, and we come into last question of lecture, which is not clearly statistical model in fact, but actually related to data analysis and solving of optimization problem. So transportation, transmission, assignment model, and solving general optimization model. So part of larger class of linear programming programs known as network flow model and possess special mathematical features that enable development of efficient, unique solution method. Linear programming means not creating a computer code, but solving of system of linear equation typically. So there is lots of usage of network optimization problem within different application and the real life. Within different in communication, in the electrical engineering, data transmission, voice message, volume transmission. So actually they are work behind the scene and allow me broadcasting this lecture. So this area which also network optimization problem and so on. So we have large number of application. Practically, we consider these things transportation system, which is maybe most easy to understand. So transportation problem deal with distribution of goods from several points of supply to number of points of demand, and they arise when cost-effective patterns need to ship items from origin that have limited supply to destinations that have demands for the good. When we doesn't have equality between request and availability, and when we want to perform cost-effective delivery with minimal cost or minimal time, which could be also important. So resource to be optimally allocated usually involve given capacity of goods at each source and given requirements for the goods for each destination. And most common objective of transportation problem is to schedule a shipment from source to destination that total production and transporting costs are minimized. Alternative tasks, which is covered by exactly the same mathematical model. It's a segment problem that's referred to class of linear programming problems that involve determining most efficient assignment of people to project sales, people to territories, contracts to bidders, and job to mechanics, and so on. Students to classes, students and teachers to classes. It's also part of creating schedule in university, creating working schedules or a list of schedules of duties, for example, in hospitals. So it's again assignment model. And mathematically, they could be solved in the same way. By objective is to minimize total cost of total time of performing task at hand. The output minimization objective is also possible. If we talk about delivery of goods, we can perform a transportation model like this in following way. There is M source, and source I has a supply capacity of S from I, and we have N destination, and demand at destination G is there from G. And objective minimize total shipping cost of supply is a destination with required demand from available supply of source. So here is given additional limitation characteristics where product transported from number of source to number of destination, minimum possible cost each source is able to supply fixed number of units for products, and each nations have fixed demand. A linear programming model has constraints for supply at each source and demand at each destination. Our constraints accurate use is balanced transportation model where supply equal demand, and constraints contain inequalities and in a balancing model where supply does not equal demand. Actually, last situation most often happens in reality. And here is we have example of chart drawing, like shipping route from source to factories to destination warehouses, or from warehouses to like shops and so on. And we can prepare every time we should have like transportation cost per desk, and then we can draw our objective like our function from objective, and here given description for coefficient and our limitation. So here is how we can turn it into mathematical model in fact. And also when we provide multiply, so here is list of constraints or limitation for specific destination and sources. So here is we can how we can calculate net flow for specific destination, and Excel contain built into which allow perform absolutely automatic calculation for our results. So what do we need? It's only a range special data set which can perform for us data for our shipping cost. We can give for us information about source and requirements for source, for destination, and then we can summarize flow in, from out, create objective function, which is multiplication in fact by two matrices, matrix of cost by matrix of transportation plan, and then just run Excel analysis tool part 2 solver and give this result which already printed in yellow. So here is solver dialog box which allow for us to provide our general settings, what we target cell, our objective function, multiplication of matrix. Then we want to achieve minimal possible value. We must change our transportation problem range for this, and here is we have limitation like flow in must be equal flow out. That's all, and Excel give for us solution if it will be possible or closely to possible solution in second. And here is only for us we have to identify a feasibility condition or balance transportation problem to get ideal solution, mathematical solution of linear optimization problem. We must have equivalence between source and amount of source and demand request. So must be passed these things called feasibility condition. But in reality we have difference. For example, when total supply exceeds total demand. In this case, we need to introduce dummy demand point, which not real, with zero cost, which will utilize our extra resources. So we need to looking for difference, and the difference will be demand for dummy point. Nothing will be transported. It's required to have correct mathematical solution. In case of supply less than total demand, much more complex, but one of solution, it's introduced dummy warehouse in similar way, which provide friction resource, which could be not could be delivered, but could be used to obtain ideal solution. And here is how it could work in Spreadsheet, and actually on practice you will do this in situation when we have like availability, a little bit different resource. We have availability of medicine warehouses, we have demand from pharmacy shops, and when we calculate real resource, real request, you can see that they are does not equal, and resources smaller than demand. So in this case, we need to introduce dummy warehouse with dummy capacity, which is difference from real resource to real demand. And for sure it must be never should be negative, so we take difference from greatest to smallest value. Also we introduce dummy cost, which is in fact every time 0, and for sure we will need adjust objective function. We apply necessary settings for solver and got their selected range, our optimal transportation plan. For sure, that's here like 120 items delivered for one pharmacy from dummy objects. It will be never delivered in reality. So maybe additional optimization could be required. But mathematically, we got optimal solution. Okay, thank you for your attention. We consider 3 questions about usages of mathematical statistical correlations and how to form statistical analysis, how to form overfitting, and even manage it with linear programming introduction. Thank you for your attention, and you can be free.